So like I say, I go through and I talk about some of the problems that were more commonly missed, but most of them I will not talk about. So if you missed them and you don't understand why, then it's your responsibility to make sure you come and see me, or call me, or email me. Somehow you need to get an answer to the question, well, how do you work this problem? Because like all math-related classes, it's all cumulative. So if you leave something unlearned at this point, it's just going to come back and bite you again on every test, including the cumulative final that we're going to do at the end of the semester. So the first page mostly went pretty well. The one about the sleep study, which I don't know if you noticed there were two versions to the test, so you have to look, see if you had version A or version B. The version A, it's problem number 4. Version B, it's problem number 2. It's a study that was done, and this is an actual study, and it gives a quote there about an Associated Press story. But I remember when this study came out that those that had longer average amount of sleep ended up actually dying sooner than those that had shorter times of sleep. But I remember when the study first came out back in, when was it, 2002, I was a new faculty member and not getting a lot of sleep, doing a lot of work, and thinking, oh good. But then being a statistician, I remember thinking, well, I wonder what kind of study that was and how valid of a study it was. And looking it up and realizing, oh, this is just an observational study, and their analyses, they didn't describe real well. And I thought, that's not that, I don't trust it that much. And then it later was criticized in the literature for lack of control of working variables. And the number one is the answer to this question. Age is a working variable. They didn't control for people's age, and what it was found was that people who were older tended to sleep more, and people who were younger, like think about college kids, how many hours of sleep do you get? 10 hours of sleep? Probably not. And you know, they're not as likely to die within 6 years because they're a lot younger. So that was the answer on that problem, was that age is a working variable. The Simpson's paradox question is the 5th question on that page, and that was pretty commonly missed. The answer is Simpson's paradox. Should fill in the blank there. A lot of people put lurking variable, and I gave you a point, partial credit, if you put lurking variable, because Simpson's paradox does involve lurking variable, but it's the fact that when you control for the lurking variable, the association completely reverses. Then it's Simpson's paradox. A lurking variable, that doesn't have to happen. It just looks stronger or weaker or whatever. Okay, let's see. On the next page, well, it actually depends on your version. Problem number 7 on version A, and problem number 8 on version B. It's the question that had a contingency table, and student and staff. That was the response, or the explanatory variable, and the response variable was the brand of car that they drive. And I asked you to do some conditional proportions about European cars. And most people did those okay. The ones who missed it typically used column totals for the denominator rather than the row totals. But it says conditional proportion of European cars of the students. So the of part is what goes on the bottom of the fraction. But then part D was real commonly missed. Probably more people said no, there's not much evidence here of a relationship than people who said yes. And partly that's my fault because I picked an example problem where if you look only at the American cars, the two are very even. The percentage among students and the percentage among staff is very, I think one's 53% and one's 55%. But when you look at European cars, and those are the two that I specifically asked you to compute, you get 10% of students and 20% of staff. Well, that's twice as many. That's a big difference. So it isn't just don't just think of it as a 10% difference, but think of it as it's double the rate. That's a pretty big difference. So that's evidence of association. So if you think about what are European cars, well, that's your BMWs, your Mercedes, your Volvos. Those are all European cars, right? And it makes sense that college students aren't going to be driving those at near the rate that staff would drive it. Right? So, that's about it, I guess, that were commonly missed. The regression problem on the back of the test went real well. Most people did that real well. There was a couple things I wanted to point out. A lot of people, part E, let's see if it's part E on both versions. No, it's the one that says explain what the value of B in the regression line represents. And there were people that gave me the definition of the intercept, not the slope, but B is the slope. Okay. There were also people that said B is the slope, period. And I remember saying in class, there will be people that answer it this way. Remember me saying that? And I will say -3. But actually it only ended up being 2 points, but -2. So even though that is true, it's not the answer. It says in the context of the problem. That means I want you to talk about hand length and height. So the right answer should be it's the amount of increase in hand length per 1 inch increase in height. That's what the B, or the slope, represents. Then when you do the predicted value, you just plug that number into your regression equation. And then the residual is the actual value from looking at the data table at the top minus the predicted value that you just computed in the one before. Now, I always want to point things like this out, and I'm not saying this to make fun of anybody, but this is a very common thing that people will write down an answer, they'll make a mistake, they'll write down an answer and never bother to look at the answer and go, well, that doesn't make any sense. Because a lot of times you can catch errors just by looking for silly things. I've had several people, no, I should say a few people, not several, a few people who answered predicted hand length with a number up in the 70s. I remember one was a 73. They predict the hand length would be 73 inches. Now wait a minute, think about that. That's a dang long hand, isn't it? 73 inches is taller than me, right? So what happened was they probably turned their X and their Y around and they predicted a height instead of predicting a hand length. But if you just think about it, wait, 73, that can't make sense. Then you catch that mistake, okay? So always take those few seconds and look at your answer and see if it makes sense, right? Okay, well, that's probably enough said about the exam. I'm willing to let you take a look at the key. In fact, sometimes I'll even have the key scanned, and then I'll post a scanned copy of the key on my courses, so I can do that. If you're interested in that and you go looking for it and it's not there, it means I probably forgot. So just send me an email and remind me, hey, can you get a scanned copy of the key posted out there so you can see what you didn't understand. But even though you get the key, doesn't necessarily mean that you understand why it's that way, especially the multiple choice. All it does is circle the right one. It doesn't explain why. So it's your responsibility to contact me and get those kind of questions answered. Why is it D and not B or whatever? Okay? All right. So enough said about that. Let's go on into section 4.2. And 4.2 is about survey samples. So this is a concept section. Really, this is a concept chapter. The whole chapter is a concept chapter. So that means you need to be very careful about reading the section, be very diligent, and make sure you look for bolded words and colored boxes and things like that, and you get all those things down. I will discuss some of these today. I won't probably get to quite all of them, which means you're on your own to read the ones I don't get to, and they're still going to end up on the homework and or on the test. Okay? So, when you talk about doing a survey, you have to first decide, well, how am I going to select my subjects? So there's good ways and there's bad ways to do that. And that's the title of this section. So the first thing we need to define is the sampling frame. And the sampling frame is defined on page 164. Nope, that's not it. 163, in one of those colored boxes. And all the sampling frame is a list of the subjects in the population from which the sample is to be taken. So it's a list of all the eligible subjects to be drawn. So if you're going to do a research study and you don't bother to think about, well, what is my sampling frame, what you may end up doing is sampling from a population that doesn't match the population that you think you sampled. Suppose you're interested in doing a survey about college students, and you envision your population to be all college students across the United States, but you select your sample using only Washburn University students. Well, you didn't set your sampling frame up to be representative of the whole population. What would the sampling frame be to be able to make inference to that whole population? It says it's a list of all eligible subjects. If you want to sample from the entire population of all college students in the United States, you need all their names. That sounds hard, doesn't it? And the sampling frame is, a lot of times, very difficult to get your hands around. And that's why they do regional surveys instead of national surveys a lot of times, because the sampling frame becomes intractable. But technically, that's what the sampling frame is. So once you have your sampling frame, then you need to decide, okay, now out of that list of eligible subjects, how am I going to select to be in my sample? So what do you suppose the most valid way to do that is? Random. Okay, so random samples. If samples are not drawn randomly, then automatically they're suspect. You start thinking, well, there might be bias in this. Did we talk about bias last time? You know what bias is, right? Okay. So a random sample is one where every individual in the frame has an equal chance of being selected. Okay. So you can't set your frame up to be all adults in a certain region, and then do your sampling technique by using the phone book. Why would that not work?
People unlisted.
People with unlisted phone numbers don't have any chance of being selected. Therefore, you don't have an equal chance. So as long as you realize, well, my population is all the people that have phone numbers in the phone book, if that's okay, then that sampling frame works, and you can do random digit dialing and get a valid random sample. But if your population is bigger than that, then that's not a true random sample. Now we're going to take this one step further into something known as a simple random sample. And a lot of times I'll abbreviate that as an SRS, simple random sample. A simple random sample is, obviously it is a random sample, but it takes it one step further. There's an additional criteria that has to be met. All possible groups of whatever your sample size is, I'll say size n, have an equal chance. Okay? So here's a little scenario. Let's say that we got, what do we got sitting in here today? 25? He's leaving, so 24.
Yeah.
25 people, and I want to draw a random sample of 5 of you. Okay? So what I'm going to do is I'm going to go around and give everybody a number, and that helps me count, see how many there really are. And when I point at you, just remember what your number is, okay? Not that it really matters, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so there's 21 people sitting in here. And suppose I say, well, let's see, I want a sample of 5, and I got around 20 people, so I'm going to take every 4th person. So you were number 1, right? So I'll take number 1, 2, 3, 4, number 5, I don't know if it was, you were 5, so you're in my sample, and go around the room like that, and I'll get my 5 people. Is that a random sample? Does everyone have an equal chance of being selected? No. And somebody numbered number 2 is not going to get chosen. Well, yeah, they could move around, but not once I've numbered them. Good thought. She said, who says you have to start at 1? So what I'm going to do is I'm going to, well, I can't really flip a coin, but I'm going to somehow get a random number between 1 and 21 and use that as my starting point. So I hit the computer and or my calculator. I'm going to show you in a minute that your calculator does have a random number generator in it. So I use that random number generator and it gives me number 16. So who was number 16? Okay. Jessica, right? I always get you two switched around. Jessica is number 16, and then I take her and I take every 4th person from there, and when I get to number 21, you're number 21 by the way, you scroll back to the beginning and just keep going. Is that a random sample?
Because there's still a set number to go by.
Does everyone have an equal chance of being selected? Yeah, they do. Because I did a random starting point. So you are just as likely as anybody else in the class to be my random starting point, or 4 people away from my random, or multiple of 4 away from my random starting point. So that is a random sample. Question?
Can you just type in that? I did it a few years ago. You just set the boundary 1 to 21, and then hit 5 random numbers.
Yeah, I'll show that in just a second. Okay, but yeah, that's what we would do. Now, does that, what I just described, is that a simple random sample? Not only does every person have to have an equal chance, but every possible group of 5 people has to have an equal chance of being selected together. Does it meet that criteria? If you think no, give me a counterexample. Give me 5 people who cannot be selected.
16, 1, or sorry, not 16, 17.
Okay?
1.
16, 17, 18, 19, and 20. 21. They can't be together, right? Not if I use that. What I described is called a systematic sample. The first one was a systematic sample starting at 1. The second was a systematic sample starting at a random number, which you need that random number to make it a random sample, but it's still not a simple random sample because 2 people sitting right next to each other cannot be in a group together, so you violate this criteria. Okay? So how do I draw a simple random sample? I want something where it's just as likely to get the first 5 people, numbers 1 through 5, together as it is any other mixture. How would I do that?
Roll a 21-sided die.
Okay? Take a 21-sided die and roll it 5 times.
Unless you get a duplicate number, that will
Okay. Okay, and that's equivalent That would work, by the way. That's equivalent to writing your names on a piece of paper and putting them in a hat, right? Drawing names out of a hat. So I would say a simple random sample is equivalent to drawing names from a hat. Now when you draw names from a hat, you sample without replacement as opposed to with replacement. And when we get to probability, that distinction is going to become important. What does that mean, without replacement?
You don't put another blank piece of paper or anything back in.
Right, you don't draw and go, oh, Eddie's in my sample, let's put him back in, reshuffle, and oh, he's in it again. Right? You don't want to sample the same person twice. So once you pull out a name, you put it off to the side and you keep going. That's sampling without replacement. If you do that, you get a simple random sample. Now, Eddie started to describe there the procedure on the calculator to do that, so let's demonstrate that. And in the book, he goes through a fairly long discussion about using random number tables, and there is a random number table at the back of the book, and I'm not going to teach that. That's an antiquated way of doing this. Almost everybody today has access to technology that will do the same thing. These calculators have random number generators built right into them. Microsoft Excel has a random number generator. Most spreadsheet programs do, and lots of other software. Right? So there's no need to draw names from a hat. There's no need to use a random number table. So on the homework, I think I've caught all the homework questions that have you do that, and I haven't assigned them anymore. But in case you see one, it says use the random number table in the back to pick. Just use your calculator to do it. Okay? Now obviously it can't be the kind of a question that's going to require a certain set of numbers to be the right answer because it's random. So all they're looking for is you to do something with that random set. So in your calculator, first thing you're going to do is you're going to push this math button. And we got 21 people in here, so we're going to pick a random number between 1 and 21. So go over to PRB, which is short for probability. So the random number generators are under the probability menu. And the top one says RAND, and that's just a straight uniform random number between 0 and 1. So if you select that, there's no need to, but if you select it, it'll come up with a number that's point something, something, something. Right? And it'll be between 0 and 1. What we want is the fifth one down, which is RANDINT. So go down and press enter on RANDINT. And it has an open parenthesis and a blinking cursor, which means, okay, I need more information. So we want to tell it that I want a random integer between 1 and 21. And it includes those endpoints. So 1, comma, 21. And hopefully you didn't have the same problems typing as I did. I have to go through this whole thing again. I was having this trouble this morning. On the screen, this thing has a delayed reaction, so you can't tell what you're pushing until sometimes it's too late. 1, comma, 21. And you actually don't have to close the parentheses, but. So I got number 20. What'd you say, Morgan? You got number 20? Who else got number 20? Almost everybody. How random is that? Hit enter now. Get another one. All you gotta do is hit enter. How many got 1? You didn't get 1 this time?
I did too.
Got 20 again?
I got 4.
Okay.
I had 10 and 10.
You got 10 and 10? Okay. What happens is when you buy your calculator, it's still set at the factory installed random seed. They call it a seed that starts these. These aren't true random number generators. They're pseudo-random. They just have to have a mathematical algorithm that has to have a starting point. And when it comes from the factory, you all have the same starting point. So you're all going to get the first number. Now, what did you say? You got 20 and 20? How many people had that sequence? Yeah, almost everybody did. Mine's different because it's on here, but actually in the other classroom this morning, I was getting exactly the same sequence as everybody else. So this one has been used in here before. Once it's been used, once you get out of sync with each other, you won't match anymore. So what you should do to get it out of sync is close your eyes and wail on the enter button some number of times. It doesn't matter how many, don't count, hit clear, then hit it again, and you should all be random. Pseudo-random, right? So I'm going to clear mine, and then I'm going to hit enter again, and I got number 3. Okay? Now how many people got 3? 1. So I would expect, now there's 21 numbers, there's 21 of you. I would expect on average 1 of you to match me. Hey, guess what? 1 person did. Right? So it's not surprising if 2 or 3 or even 4 of you match, but when half the class says, I got the same thing, then you know something's funny. Now, person number 3, that was you, right? Person number 3 is in my sample. So I need 5 people. Person 15, who's that? You guys weren't paying attention. Hillary? I like it. Was I 15? Yeah. Okay, so Hillary's in it. 21, that's Logan. 14, that's Emily. And number 7, hey. Okay, there's my 5 people. Now, what would have happened if I'd have got duplicate numbers? This is equivalent to rolling a 21-sided die, which is sampling with replacement. What do I do if I get a duplicate number? And did some of you get duplicate numbers when you did your 5? Yeah. If you do, you just ignore, oh, 6 came up before, so you just hit it again, ignore the duplicate 6 and go for whatever's the next number. Okay? Now, you can kind of shortcut this a little bit. You can go back to PRB and rand int and put in your 1 to 21. Now when I hit backspace, it disappeared. Let me,
when you go to map, you can hit left and then 5. That way you don't have to arrow so much.
yeah, I hit backspace instead of arrow, and that was the problem. Then go put in 5, and that extra 5, which is not required, but it tells it, just give me 5 of them at once. So I put in 1, comma 21, comma 5. And I press enter, and it gives me 5 of them. In my case, I got 5 unique numbers, so I'm good to go. Did any of you do that and get a duplicate? So now what do? You got 3 times? Wow. You need your calculator. Just kidding. If you get duplicates, then you have to ignore the duplicates. Well, the thing that the book says to do, and this is a good suggestion, instead of telling it I want 5 numbers, tell it you want like 8. And then if you get a duplicate, you ignore the duplicate, and you still have another one left over, right? So, but in this case, if you got a duplicate with 5, you can just hit it again, get a new 5, and take the first of them that's a new unique number until you get 5 unique numbers. It's all random, so it doesn't matter how you piece them together. You don't invalidate the randomness by having to hit enter again. Okay? So that's how to make your calculator draw a simple random sample. Now obviously if you wanted to do a simple random sample of 50 Washburn University students, and there's 7,000 students, then you got to number all 7,000, and you got to get software that'll give you those 50 numbers, right? So it's going to be tough to do on your calculator, but you could work it out. But other computer programs are going to be a little more sophisticated in helping you to draw those kind of samples. Okay? Now, let's talk about, once you've selected who your sample is going to be, how do you conduct your survey so that you get valid results? So, we talked a little bit last time about bias, right? Bias will tend to invalidate your results. So what we want to do is talk about ways to sample that do not have bias. So there are several different kinds of what we call sampling bias. Specifically, well, let me go ahead and list them. Sampling bias, response bias, and non-response bias. Three different general categories of bias, each of which has several different types, subcategories within that. Sampling bias is any kind of bias that results from the way you drew your sample. Okay? So I'm just going to write underneath it, bad sampling. So if I didn't use a random sample. One of the terms in this section is called voluntary response survey. Have you ever, I know you've seen them, but you may not have known what they were called. A voluntary response survey is like when you open a magazine and a little card falls out of it and it says, please take our reader poll. Answer these 5 questions and drop it in the mailbox. That's a voluntary response survey. Or you're watching the news and they say, and Channel 13 here in Topeka does this all the time. They'll say, our viewer poll. The results of tonight's viewer poll is that 61% of you feel that he is guilty. And the rest of you, whatever. The question of the day kind of thing. That's a voluntary response. They're not drawing a random sample of people. They're just saying, okay, whoever calls it. You see them on the web a lot too. You'll go to a web page and over in the right panel it'll say, take our survey. Click here if, whatever. Who actually clicks on those things? Who calls that phone number? Okay, and why, he said people that want to. Well, what would make somebody want to enough? Most of us ignore it, right? They've had a bad experience with whatever that question is, or in some other way, they feel strongly about that issue. So what you get is you get a sample of people who really have strong opinions about that issue, and everybody else who's kind of in the middle of the bell-shaped distribution, they don't bother to fill it out. You think that might be a biased survey? Yeah, that's pretty biased. Right? I remember once, they used to have this column called Ann Landers. Do they still have that? Yeah, Ann Landers. And Ann Landers is always notorious for doing these kind of voluntary response polls. And one of them was, Ann Landers' poll shows that 75% of married women have cheated on their spouse. And I read that and I thought, oh crap. So I confronted my wife. No, it was a voluntary response survey. Who's likely to answer that question? Most women don't ever bother to send the card back in. But those that have cheated on their spouse, they want to feel like, well, everybody's doing this. Well, yeah, and they send it in. Sure enough, you get biased results. And they have done a true random sample, and the rate is much, much lower than that. Down in the single digits of percent of women and of men that have cheated on their wives. Now, who do you think is a higher rate, men or women? Men is a higher rate, but both, they're lower. Much lower than 75%. So bad sampling. Voluntary response is the ultimate bad sample. Right? There's a great example in this book. If I have time, I'll talk to it, but it doesn't look like I'm going to. Example 7 about a literary digest poll. I may spend a little bit of time talking about it next time because it's such a neat example. Next type of bias is response bias. This is bias that results in the way people answer questions. So they answer the questions incorrectly for one reason or another. So suppose I'm interested in doing a survey on illegal drug use among college students. So I use a technique known as personal interview. This is another term that's in the book. So I just come in the classroom and I draw a random sample and, hey, Logan, are you now or have you ever used illegal drugs? What kind of a response am I likely to get from him?
A lie.
A lie. Well, that's assuming he's guilty. Right? If he has used illegal drugs, he's probably going to lie. If he hasn't, he'll tell the truth. Either way, he's going to say no. Right? Oh, did I mention I'm in my police uniform? Right? So that's a personal interview leading to response bias. People answer either intentionally or sometimes unintentionally. They give the wrong answer. How could it happen unintentionally?
Maybe they don't understand exactly what the question's asking.
Perfect. They don't understand the question. One of the things that if you ever do survey research, one of the things that you have to understand is that you need to pilot your survey to other people. Say, read these questions, do they make sense? And it's called a focus group. And that focus group can help you. Well, you kind of worded this one a little bit funny. I wasn't sure whether you meant this or that. If they don't understand the question, then there's no way you can trust that their response is the correct response. Here's another way that you can get response bias. I'm doing a survey today, Delaney, and I want to know how you feel about the use of disposable diapers versus cloth diapers. Knowing that annually disposable diapers are responsible for millions of tons of extra refuse in our landfills.
One-sided answer.
Yeah, what I just did is known as a leading question. What I did was I enclosed in the question the answer I want to get. I made it very clear to her which way I wanted her to answer that question. Lots of surveys are done this way. They're not valid surveys, but a lot of company-sponsored surveys, they'll word the question in a way that makes people know what the answer is. Now, most people, like Delaney, I'm sure, are really nice people. And they want to tell you what you want to hear. So if she knows I want her to answer a certain way, she probably will. Either it's because they're nice, or it's because if I answer the other way, I may get into a 30-minute debate with this person, and I don't have time for that. So just tell them what they want to hear, and I'm going to be on my way. Either way, it's a biased response. If I want to ask about drug use, how should I conduct that survey? Anonymously. So describe a scenario that would be anonymous and make Logan feel comfortable that he could answer in whatever way was truthful.
Maybe it was like survey on paper.
Okay, on paper, without a personal interview, on paper, with no place for any kind of identifying marks, and even, you could even go as far as have like a voting booth where you have a curtain you pull and you go in there and you fill out the survey and you drop it in a slot, right? And there's no way that they could ever trace who filled what out. Then you'll get valid responses from that. Okay? So you have to be very careful with how you ask certain questions. There's been a lot of survey methodology research done, and the book has several examples that talk about these things. I won't go into each of them in detail, but one of them they talk about is race relations. If you're going to ask racially sensitive questions, just a simple question like, do you feel that racism is a big problem in this country? Right? You ask a question like that, and suppose you do it by phone interview. Well, when you hear the voice on the other end of the phone, we all make judgments about who that person is. Right? If they have a foreign accent, or they sound like they're from Minnesota, see how I tried to do it? Minnesota? Well, if they sound like they're from Minnesota, you probably figured, well, they're white, right? So you can judge race, you can judge nationality, a lot of things just from the voice on the other end of the phone. Well, what they've shown is that when you ask the exact same question about race relations, if they perceive that the interviewer was white, they had a completely different percentage of yeses than if they perceived that the interviewer was black. Completely different. Like the yeses were 60-some% and then they went down to 40-some%. You know, whatever the question was. So, phone interview, the next one after personal interview is a phone interview. That can have biased results if you have sensitive material you're asking about. If you're asking about how many kids do you have, no problem. Don't worry about that. Right? But you have to think about, well, what kind of questions am I asking, and is there the potential for bias because people don't want to have confrontations with whoever's on the other end of the phone, right? Again, they tell them what they want to hear. Okay, now non-response bias. What do you suppose that refers to?
You send out 50 flyers and you only get 12 responses.
Okay, you send out 50 flyers and you get 12 of them back. That's a lot of non-response. Okay? If you send out 1,000 surveys by mail and you get all but 10 of them back, don't worry about it. Those 10 aren't going to be enough to really invalidate your responses. But if you send out 1,000 surveys and you get 100 back, what was your non-response rate? They call that the rate of non-response. 90% non-response rate. If you only got 100 back, you got 900 that didn't come back. Right? Then you have to really think, well, I probably have some non-response bias. If that happens, it really turned into a voluntary response survey, didn't it? If you only got 100 back. So, non-response. Here's an example of non-response, a little more play acting here. Suppose I'm doing a survey and I'm going door to door. And I knock on the first door. And the door flings wide open and there's this really cute little blue-haired old lady. And she invites me in, sets me down on the couch, gives me cookies and punch, and sure, I'll take your survey. And she spends an hour and a half with me filling that darn thing out. Right? Then I go to the next door. I'm thinking, this is good. I go to the next door, and I get this. And all I can see is an eyeball through a tiny crack in the door. What? I'm doing a survey. Slam. Non-response. Do you think there's anything systematically different in the way those two people would answer the questions?
Yeah.
And since I only got one of their answers and I didn't get the other one, that's bias. I'm going to systematically overestimate the positiveness and underestimate the negativeness, right, of that kind of a scenario. So you have to be very careful about too much non-response. So when you really do a survey, a lot of times they'll try to recapture some of that non-response. What do I mean by that? Well, they mail it out, they get 100 back, so they take the 900 they didn't get back and they remail them with a little bit of a guilty, to make you feel guilty. We noticed you didn't return the thing. We really need to have your answers. Please send it back. And then if you still don't respond, maybe they call you, right? So you try to capture your non-response. That allows you to do two things. Minimize the amount of non-response, but also estimate, okay, in the original one, were the non-responders different? Because now you've captured them. Were they systematically different than the responders? If the answer is no, they really answered about the same way, then you don't worry so much about going to great lengths to get the rest of them. But if you say, ooh, they're different, I need to capture those. Right? All right. Like I said, I didn't quite get every term in that section, but your homework over this will be due Wednesday night. I've said all I'm going to say about this section. So Wednesday night by midnight is 4.2. Tonight by midnight is 4.1. Don't forget. All right, we'll see you Wednesday.